Hello everyone, welcome to my channel, and today we'll be discussing about the continued series on Terraform. So if you haven't watched my first video on Terraform, I would suggest go watch that video and come back to this video. In first tutorial, we talked about the key idea behind infrastructure as code. We talked about the Terraform, how to install it, how to set up our work environment, and then we created a basic main.tf file where we defined all the resources as you see over here. In summary, this was the simple Nginx web server that we created in AWS. We deployed it in US East 1 and we had a VPC CIDR block of 10.0.0/16. We created a public subnet with an EC2 instance and we deployed Nginx service in it, and we created a security group and we created a ICW, which is an internet gateway for traffic to pass through to the internet, and we described the route table. So the base configuration that we deployed earlier in AWS is hard-coded, and later on if we need to change these values we must modify our main configuration file. So here we'll learn how to supply input values for use in configuration, and we'll look at how to construct those input values inside the configuration for reuse. Terraform accepts value as input, it transforms the values inside the configuration and returns values as output. So these are the three different concepts that we have to consider when working with data in Terraform. So the first is input variables that are used to pass information to the Terraform configuration, and these variables are defined inside configurations and values are supplied when Terraform is executed. And then we have local values, also called locals. They are computed values inside the configuration that can be referenced from anywhere within the config. And then we have data that is returned by Terraform with output values. So the outputs are defined in configuration and values of each output will depend on what is referenced inside the configuration. And just like locals, output values can be constructed from one or more elements. So let's understand how variables are described. So variables are described in a block that starts with this variable keyword, and then it is followed by this single name label, and all other properties are defined within the block. Let's look at what are the arguments that can be passed within the variable block. So these are the list of available arguments that can be passed within the variable block. The first one is default, where default argument allows you to set a default value for variable, and if no value is specified then it will use the default value. Then we have this type argument. Type argument is used to specify what value types are being accepted for the variable. We'll look about different type of data types that can be passed in Terraform in a bit. And then we have a description argument, which, as the name suggests, is just for the documentation purpose. And then we have validation, which is a block to define the validation rules, usually in addition to any type constraints. And then we have this sensitive argument. Sensitive argument accepts Boolean values of true or false. So you can imagine that sensitive argument can be useful when we have to submit some potentially sensitive values, like for say password or any API keys that you don't want to display in any logs or you don't want to display in your output terminal. And then finally we can pass the nullable argument, which is used to specify if the variable can be null within the module. So this is how your variable definition would look like. You start with the variable keyword and you give a name label. So for example, let's say we want to have an AWS region definition. So the variable name would be AWS region, and then the type specifically defines what type of values we want to provide. In this case, we for sure know that AWS region is a string type, so we passed in string. So if you pass any other variable other than string, then during the Terraform execution it will fail. So the next is description, where we provide the description for AWS regions list, and then we passed in a default US East 1. If we don't specify any region, then by default it will build our resource in US East 1. So if you remember, we had this sensitive argument that we learned earlier. By default, sensitive is false, and we don't need to put any sensitive to true in this AWS region because it's not sensitive as the password or any API key. So now let's look at what are the type of variables that can be passed within the variable block. The first data type that can be passed is primitive, and primitive types are string, numbers, or boolean. And string are a sequence of Unicode characters. Numbers can be any integer or decimal, and boolean is either true or false. And then we have collection data types. So the collection types are lists, maps, and sets, and collections are typically the grouping of the primitive types, but each values stored in these collection data types must be of same data type. So if you see here, list is ordered group of elements like the numbers 1, 2, 3, 4, or the AWS regions, US East 1, US East 2, etc. And set is unordered group of elements, whereas map is a group of key value pairs like small, medium, and large for the instance type definitions. And then we have structural data types that are similar to collection data types, except that they allow you to mix the data types stored in each grouping. So tuple is similar to lists and object is similar to maps. So if we want to use collection for a variable, let's say for AWS region, the type argument takes the form of collection type we'd like to use and what data types will be stored. So for example, let's say for list of strings, the variable definition would look like this, where we have a variable block, as we discussed earlier, we have a name definition or the name label, then under the type argument we have list of strings. We provided the basic description, and in the default section we provided 3 list of strings, and then we provided the sensitive to be false. But as I said earlier, you don't have to necessarily pass this information, as by default it's false. So list is an ordered data type, and we can refer to the element that is stored in the list by the number which is starting with 0. So if you want to refer to the first element, let's say for US East 1, you would have the pointer set to 0. So that means to reference it, we use a var identifier followed by the AWS region as the name label, and then we can pass in the first list, that is 0. If you want to refer to US East 2, you would update it to 1, and so on. And for the whole list, you would provide just var.aws region without any element in the square bracket. Similarly, for map string holding the AWS instance sizes, you can write a variable block as shown here. So here we started with a variable block as we did earlier with a name label, and we provided the type argument to be map string, we provided the description, and in default provided the map of strings. So if we want to reference the values that is stored in these keys, there are 2 ways of doing it. The first one is to use a var identifier followed by a name label and followed by a key name. So to refer to the values that is stored in this small key, we would provide something like this, where we use a var identifier followed by the name label AWS instance size followed by dot small. Or there is another way to refer this. So you can use this var.name label, and in square bracket you can provide the key name. So for referring the value stored in same small key, you can use var.aws underscore instance sizes and small. Now that we understood how to define the variable block and what are the different arguments that we can provide within the variable block, now let's go ahead and define different variables in a variable.tf, and we can reference those values in the main configuration. For that, I'll go ahead and create this file called variables.tf in the same directory where my main.tf is hosted. And to make it easier to compare, let me split the screen so that I can compare in here. So the first thing that I want to do is I want to create a variable for access key. For that, I would use a variable keyword followed by the name label, let's say AWS access key, and then I can have the variable block where I can provide the type. I know the type for the access key is string. Then I can provide a description that reads as AWS access key, and then in the final section I can provide the sensitive where I can set it to true, because I don't want my access key to be displayed anywhere in the logs or in the terminal. So similarly, I can create a variable for AWS secret key, and it would look something like this, where I provided the variable block followed by the name label, and similar to how we described the access key, I can do the same definitions for secret key. And similarly, let me go ahead and do the variable definition for AWS region, which would look something like this. Now that I have my variable definition set, I will go ahead to my main.tf and provide a reference to those variables I just defined. So for the access key, I can go ahead and remove the hard-coded value, and I can use a var identifier followed by the name label I provided in the variable definition. So similarly, I can do the exact same thing for secret key, where I'll go ahead and remove this and provide a reference to the AWS secret key variable that we defined earlier. So similarly, for region, I'll go ahead and remove this and provide a var pointer to the AWS region that we defined in here. So don't worry about all this variable.tf and main.tf and all the files that is in the main directory. I will post these in my GitHub repository, and I'll post the link in the below description. For the understanding purpose, I will go ahead and scroll in main.tf. Now I have this resources section, and I want to create the variables for the resources wherever I can. So I can go ahead and put a variable for the cider block. In the same way, I can go ahead and use this enable DNS hostnames and create a variable for DNS hostnames. Similar to this, if I scroll down, I have this subnet section where I can put in variables, like I can define a variable for VPC subnet 1 CIDR block, and in the same way, I can define the variable for the map public IP unlaunch and set it to true. If we scroll down, I can see that I have my instance definition where I have my instance type hard coded. So what I can do is I can use the variable section to define the instance type variable. So now I'll go ahead in my main.tf and use a pointer to point the variables that I just defined. For the CIDR block, I can remove this hard-coded value and use a var.vpc CIDR block because I have this CIDR block defined in here. Similarly, for the DNS hostnames, I can go ahead and remove the hard-coded value of true and I can replace it with var.enable DNS hostname. So pause this video and go ahead and use all the pointers in your main.tf and come back. Now this is how my final main.tf will look like after referencing all the variables that I created in my variables.tf. Now that we talked about input variables, let's talk about output variables. So output values are how we get information out of Terraform, and outputs are printed at the terminal window at the end of configuration run. Now to create the output variable for my configuration, I'll go ahead and create a file in the same folder called outputs.tf. And then to make it easier, let me split the screen. I want to print out the output of the public DNS hostname for my EC2 instance. So I'll go ahead and update my outputs.tf file. So the syntax for outputs is pretty much similar to how we defined in input. So we start with the output keyword followed by a name label, and we have certain values which equals to some output value. But we would have to replace the keyword with output and it follows a name label. So for the public DNS hostname, I would put something like public DNS hostname, and then it follows with the output block. So within the output block, I want to supply a value and point it to the AWS instance, which is the name label or the label that I used in my main.tf, and followed by the nginx1 public DNS, where nginx1 is the name label that I provided to the instance resource block, and public DNS is the public DNS attribute of public web server EC2 instance that I want to be displayed. Similarly, I can have other optional parameters, like I can set the description to something like public DNS hostname. Now that we have the output variable definition, let's talk about locals. Local values, as we discussed earlier, are like a function's temporary local variable. So these are the values that are computed inside of the configuration. So in order to define the local variables, I will go ahead and create another file called locals.tf, and I will split the screen to make it easier for us to compare. So the syntax for the local variable starts with the local keyword followed by the block. So here it has multiple key value pairs, and the value can be any supported Terraform data types like string, list, objects, etc. Let's say we want to declare the two common tags for all the resources that are defined in AWS. We can define common tags in the local value and use that value throughout our configuration. So let's define that. So within this local file, I can create a definition such as this, where I used a local keywords. I can define instance prefix, I can give it a service name, and here I define two company tags, the company and the project. So I can go ahead and use these common tags to refer all the resources within my main.tf. So let's start with the networking. Within the networking, I can give a tags as local.common tags. So if you noticed, the locals definition within the local.tf is plural, whereas the reference definition that I used in main.tf is singular. So you have to be careful on this. Similarly, I can go ahead and do the tags definition or the local definition in the AWS Internet Gateway, in the subnet, and I can do it in the routing section, the security group section. Similarly, I can do it in the main instance definition. So what we did is we defined our local values and referenced those in the main.tf. You can either use the company name directly, or since we are using a variable, let me go ahead and use the var.company. So now that we have the local definition, we want to go ahead in our variables.tf file and create a variable definition for both the company and project. So for that, I'll go ahead and create two variable blocks for company and for project. So I provided the variable company and provided the default of techie and travel, And for the project, I provided the type of string, and I have this reference in here. Next, I'll go ahead and save both of these files, and then I want to discuss about validate. So Terraform has a command called validate that helps to validate if our configuration is correct. So to do so, we have to run Terraform validate, but before that you have to initialize the directory. Since I already initialized the directory in my last tutorial, I'll go ahead and run Terraform validate. So Terraform validate, it checks the syntax and logic of configuration to make sure everything looks good, and it will print errors if it found any errors in the line where it finds the issue. So to make sure that it actually detects the error, let me go ahead and replace this block with something like name, and let me save it, and let me run Terraform validate again. So it should detect this error that I provided in here and point me out that I have an error in my main.tf. So let's confirm that. So as you see, it pointed out that in this specific section, the input variable with the name VPC cider name has not been declared. So if I go back and update is to block and save it and run Terraform validate again, it should give me the success screen. So here you see that our configuration is valid. So this is a good way to check whether your configuration is good before actually running it and implementing it. So now we have all the variable definition, we have output.tf, we have local.tf defined. Now we look at how to supply the variable values. So there are different ways to supply variable values. You can set a default value in configuration, which we did in our config. Then you can use -var flag followed by a variable. You can also have all the variable value in a file and submit that file with var file flag. There are also other two ways to submit a variable via file. If there is a file in the same directory as configuration and it's named terraform.tfvars or terraform.tfvars.json, Terraform will use the values it finds in this file. And additionally, if there is a file in the same directory as configuration ending in .auto.tfvars or .auto.tfvars.json, Terraform will use those values as well. We can also use environment variables to set variables in Terraform. You can simply do this by exporting your variable, and Terraform will look for any environment variable that starts with tf_var_ followed by a variable name. If you don't submit a value for variable in any of these ways, Terraform will prompt you for the value at the runtime. Then you might be wondering, if you set the same variable in multiple ways, what is the order of precedence? So there is a variable definition precedence you need to be aware of when declaring variables. So Terraform loads variables in specific order. First, it will look for the environment variable. Then if present, it will look for the terraform.tfvars file. Then it will check the terraform.tfvars.json file if present, and then it will look for any var file options on the command line, and then it will proceed with the var options on the command line followed by the command line prompt. Next, we'll look at how to deploy our configuration. So reviewing the variables in our configuration, there are few that does not have default set, like AWS access key, AWS secret key, and project. All the other variables have default set, and we can go ahead and keep using that. Now let's see the potential syntax if we want to submit the values for all the variables via command line. So we can initiate Terraform plan, and with the -var flag, we can provide the value for the project. Similarly, we can provide the value for the access key and secret key. This command can get very long, and there is a simpler way to do this. So let's go ahead and use this. So here in the main configuration directory, I will go ahead and create a file called terraform.tfvars, and within this file, I will use the project variable that I had earlier. So for the project, I will use demo.webapp. Next, we have access key and secret key, but we don't want to store our access key and secret key in a file. So we will instead use them in a environment variable. So let's save this and let us close this. And next, we will go ahead and open the terminal. Next, we are going to export the two environment variables for our secret key and for our access key. So depending on whether you have a Linux-based OS or a Windows-based OS, you use the export options to export the variable. So since I'm using the PowerShell, I'm going to go ahead and copy this and paste in my command terminal. Similarly, I'm going to copy the environment and paste it in the command line. Now that I have my command line configured for environment variable, I'll go ahead and initiate the Terraform plan. As you see, our Terraform plan got initiated. Let me expand this, And here we can see that it's going to build all the instances in our availability zone. So if you look at the end, it says that it plans to add 7 resources. And once you apply, it's going to give the public DNS hostname. So just go ahead and execute Terraform apply. So it will go ahead and build all the resources and give you the public DNS hostname at the end. So this is it on the second part of Terraform tutorial, where we learned how we can update the main.tf that was hard-coded and use the separate locals, outputs, and variable file so that we can make it dynamic. Now we can just pass the Terraform variables either through terraform.tf bars or through the command line and make it more dynamic and use it for different environments. Like we can use it for prod environments, we can use it for development environments, or any other environments. So in the next tutorial, we'll look at modules, and stay tuned. Thank you.